So we are going to solve the question and then okay, we before we solve the question, there are some things we still need to know. Then there is this law guiding electrolysis. That's the Faraday's laws of electrolysis, first and second laws of electrolysis. So that the two laws will guide us in the calculation that has to do with electrolysis. And the first law is saying that the mass of a substance formed at the electrodes, or in the mass of a substance deposited at the cathode, or to put it better, the mass of a substance liberated or deposited during electrolysis is directly proportional to the quantity of electricity passed through the solution. So what it is saying? We have seen that during electrolysis, at the end of electrolysis, we are going to have some products formed. In our example here, we take you so for the two products are hydrogen gas and oxygen gas. Hydrogen gas are the cathode, oxygen gas are the anode. Then, if you now want to measure the quantity of these products formed, because if you are to employ this method in the industry, we are interested in certain quantity. So we must know how much can we get from this. So the law is telling us that the amount in mass, eh, the mass of any substance formed is directly proportional to the quantity of electricity passed, which means the more electricity you pass through the solution, the more the quantity of the product you're going to get. So when we say OH ion, hydrogen ion are transformed into oxygen, it does not necessarily mean that the whole of the hydrogen ion present in solution is going to be transferred. It all depends on how much electricity you have passed. So that means at the end of the day, you may still have some left unconverted. So it depends on how much electricity you have and how long do you pass it. All are lumped up in the quantity of electricity. Because this quantity of electricity itself is a direct function of the current and the time. So how much current are you passing and how long do you pass it? You may pass a particular current if you pass a particular current for a shorter time. So what you are going to get will be less than if you pass the same current for a longer time. You understand? So current, the duration of the passage, the product is what we call the quantity of electricity. So which if you know the current and the time, multiply that, you're going to get the quantity of electricity. So the quantity of electricity is measured in coulomb, symbol C. Current in ampere, and then time in seconds. You understand? So this is Faraday's first law. Faraday's first law of electrolysis. That what the mass is proportional to the quantity of electricity. The mass of the substance formed is proportional to the quantity of electricity. And the quantity of electricity is measured by multiplying the current and the time together. The unit is coulomb, unit of current is ampere, of time is seconds. So that's has to be understood. Then as for the second law, it is possible for us to have two or more solutions being conducted at the same time. So we want to use the same quantity of electricity to conduct electrolysis of different solutions. Like we have H2SO4 here, we might have copper sulfate here, then and so on. So we want to use the same electricity, pass the same current to, through all of them. So in such case, then to determine the amount of substances formed, the Faraday second law helps us out in that aspect. That the number of mole of the various of a substance formed is inversely proportional to the charge on the ions of that. What is the second law telling us is that supposing in an electrolysis we have electrolysis of silver nitrate and then electrolysis of copper sulfate. Then we have copper sulfate solution in one electrolytic in one voltmeter. Then another one is silver nitrate in another. So the setup is usually like this. It could be more. So we decide to pass just one current through. Understand? So they are connected. Then let's say this solution here is silver nitrate solution, then it is copper sulfate solution here. Then the second law is telling us that in this case, if the number of moles, let's say at the end of the day, silver, the metal silver is deposited at the cathode, the metal copper is deposited at the cathode of this solution also. These are the products of interest. Then if you want to know the number of mole of the silver produced with respect to the number of mole of copper produced, then the second law says that they are inversely proportional to that each charge of, let's say, A produced is, the mole is inversely proportional to the charge. So let's say the charge is Q, charge on the ion. So silver solid was actually formed from silver ion. So when silver ion discharges at the cathode, it forms this. When copper 2 ion discharges at the cathode, it forms this. So the law is telling us that the number of mole of, let's say, silver formed now will be inversely proportional to the charge on its ion. So if you are to join these together to get an equation to simplify the whole thing, it means we have silver formed here, copper formed here. Then the ratio of their moles will be what? Equals to the charge Q of copper and then the charge Q of silver. So which means if you have 2 moles of this, we don't know how many moles of this. And then we know the charges because the charge on copper is 2. Cu 2 positive. The charge on silver is 1. So we just write 2 over 1. Then multiply by whatever the number of mole of copper is giving. If you multiply this ratio by it, then it gives us the number of mole of silver that is formed. So that is the what do I call it? The second law of electrolysis. Then in furtherance to this, that is another thing we need to know. Like I mentioned before, that the electricity, sometimes the question can come specify the quantity of current or the quantity of charge pass or the number of Faraday or the number of electrons involved. So we could see from our ionic equations where we have 4 electrons in the case of the OH to oxygen. Then in the case of hydrogen, we have two electrons are involved. So there is, let's say for instance, the formation of copper from copper 2 ion. The formation of copper from copper 2 ion, like I said, a positive ion will have to gain an electron equivalent to its charge, then it will form 1 mole of this solid, copper solid. So we cannot say in this question that 2 moles of electrons is required to produce what? 1 mole of what? Copper. So alternatively, this 2 moles of electron is the same thing as 2 Faraday. If it is 1 mole of electron, then it means we need 1 Faraday to produce 1 mole of whatever you have here. So 1 Faraday to give 1 mole of copper. And 1 Faraday of electricity has a value. 1 Faraday of electricity, like we said, has a value in terms of coulomb, in terms of charge, equals to 96500 coulomb. You understand? It has this charge. C means coulomb.